Now that we've got our core kind of ripple distortion effect, we want to add some movement and a little more control to it. So what we're going to do is we are going to add a node which is going to allow us to add some movement. And so this is going to be if we search for time, there is this time parameters node. And the time parameters node has a couple of different outputs. So this is a float in seconds from when the application started running. Now what we are going to do is we are going to connect. So we're going to take our time and we're going to take our screen position and use them to scroll the UVs on the distortion map. So first, what we're going to do is we are going to add in the slightly hilariously named swizzle node. I can't believe this is an actual word that we're going to use in our training, but swizzle is the actual technical term. And what swizzling is when we're talking about graphics programming is it allows us to reorder the components of a vector. So, or to modify the components of a vector, right? So let's say I had I actually do have a vector 4 coming out of my grab screen position, and I wanted to, instead of having it be XYZW, I wanted it to be WZYX, right? I want to invert the order. I could pass it into a swizzle node and say, okay, the output type is going to be or YYZW or YYZX or whatever. We can mix around the order of the components in a vector, and the word swizzle comes from swizzle stick, which is to mix a drink, right? So you use a little stick to mix your drink. In this case, we're using a swizzle technique to mix up our vector. Now, we're not actually really mixing much. We're just going to basically use this to cast our vector 4 to a vector 2 and discard some of the components. So we are just going to set the output type to vector 2 and connect that to our UVs. And what we want to do is, actually before we connect this, we're going to connect this to another multiply node so that we can scale the amount, right? And again, we're going to multiply by a float. Okay, so we're going to take the swizzle output, we're going to multiply it, and we're going to multiply it by a float called ripple scale. And this is also going to be a property, and it's going to be between 0 and 20. So this is going to allow us to scale the size of our ripples. And we're going to send this into the UV output of our distortion map. Now, the input to the swizzle is going to be the existing screen position added together with the time, and the time is also going to be connected to a multiplier node. So first, let's actually add the add node. And one input for this is going to be the screen position, right? So notice we have two outputs from our screen position, right? So we're going to have the original screen position passing through and this added offset screen position. And then we're going to add a multiply node. We're going to take the middle t value, and each of these are different. This is t divided by 20, multiplied by 2, multiplied by 3. And this, I believe, is a vector 4 with all the values. Not sure what you would do with that. And so this is time that's flowing in from Unity. This is like, I think this is equivalent to time.time. It's a float in seconds. And so what we're going to do is we're going to pass that as the the other input to our add operation, and then we're going to add another property, another float as the, as the scaling value for this. And this is going to be called ripple speed. And this will be between 0 and 1. And it's going to be a property as well. And now, okay, so we're going to scale that using the multiply node, add it into the screen position, swizzle it to a vector 2, and pass it through to the distortion map. So that actually should give us everything that we need. So now, if we, so we're going to need to enter play mode to see this actually working. Let me just take a look at it, make sure it looks correct, which it does. Okay, good. So now we're going to update our graph. We will see in our material that our new properties have appeared, right? Let's turn them up a little bit. So now we can have just sort of 0 ripples, or actually, wait a minute, that doesn't look right. Okay, so just to recap, right? I looked at my shader and I noticed, and this was just because I was messing with the swizzle node to demo it, but I noticed, right, that I was getting this weird, excessively kind of one-dimensional, you can really see it there, right? It was turning it into lines, and what had happened was I had failed to set my swizzle back to X and Y instead, and it was on Y and Y, right? But that's actually a pretty good demonstration of what swizzling does, but not what we want, right? So we're going to set the swizzle to X and Y as it should be. And now, and update. There we go. All right, good. And so now we can see we can adjust the ripple scale, right? Get this very noisy kind of look, or just a straight offset, right? We can see here, this is just moving the pixels, which also looks kind of cool. I like just a little bit of scale, so we get some nice distortion there, and a little bit of slow speed, which we'll need to go into play mode to test. And so update that. And now what I'm going to do, so now we've got our new material. So I'm going to delete this arm because my demo won't work with 2 arms in there. Okay, and so with the arm deleted, I'm going to actually just set this manually to make it easier to demonstrate the material. So let's enter play mode, pause, and we're going to grab the arm, and we're just going to assign our material directly to it so that we don't have to keep changing it back and forth. And now we can see, if we take a look at the material, we can now adjust the ripple speed and have it rippling really quickly. Or I like a kind of a nice slow speed. I think that gives a nice effect. We can adjust the scale, which gives us sort of smaller, noisier looking ripples, or just a straight displacement effect. I like a little bit there, I think is kind of nice. And then we can also adjust the distortion. This could be a cool thing to automate as well. But I think a little bit there is nice, and then we can kind of, let's give it a little bit more. Maybe something like that. And we can see our effect working there. Okay, very good. Oh, and one last little, before I recap, one last little touch that we can do to this is pass through the lerp output to both the metallic and the smoothness nodes here. And what this will allow us to do is to just, it doesn't really work very well in this scene because the skybox is black, but what it'll do where we have a lighter colored skybox is give us a nice little kind of rim lighting effect around the arm. because we're going to get some extra shininess from the metallic and smoothness channels. So just a little detail to add there. I can't really demo it because my skybox is dark, but there you go. So yeah, so there we've kind of seen constructing a shader from scratch in Amplify Shader Editor. So just to recap, right, we're passing in black to the albedo color so that we're not tinting it. We have our grab screen color, which is getting the color of the pixels behind the arm. Our lerp to white, which we're doing to fade in and out of the invisible state. And then we're doing a fair amount of work with the screen position to move around the pixels that are being seen through the arm using our ripples, our distortion map, and then our various properties that allow us to scale and control those things. So there you have it. Thanks a lot for watching. I'm going to stick around and take some questions from the chat, but hopefully this gave you some ideas for your own custom shaders. Thanks. Oh, and actually well, this doesn't need to be in the main thing, right? But the other thing that is worth noting is this is actually generating a text-based shader, right? So let's update it. You can actually look at this shader. If you highlight it, you can open it in a text editor like MonoDevelop. And you can see here is all the text-based shader code that's been generated, right? So you could edit it here if you wanted to. And then down here, this is all the kind of metadata for the graph, for the node graph. It saves it basically in a kind of a comment inside the shader, which is kind of interesting to see. So yeah, just FYI, you can open these and you can edit them as text as well.